So basically, we will be learning about how to run Apache Kafka natively. That is, running Apache Kafka without JVM. So we will explore that how we have created a native executable for Apache Kafka and packaged into a highly efficient Docker image. Yeah. So we will kick things off with an introduction to the native Apache Kafka Docker image. We will then look at the optimizations that we have made to this image and compare a few numbers of this image with the other previously available open source Apache Kafka Docker images. Next, we will take a quick tour of the GraalVM native image tool and how we leveraged it to create the Kafka's native executable. Additionally, we will be sharing the key insights that may prove very effective to use this Docker image in a better way. We will also demonstrate that how can we do a quick start of a Kafka container using the Docker image and explore the various methods of how we can customize the configurations. Lastly, we will explore how this Docker image can be integrated with the test containers and along with some limitations to keep in mind. So let's get started.
All right. So native Apache Kafka Docker image was delivered in KIP 1074. This was delivered by Apache Kafka community. And this Docker image is very highly optimized for small size, very fast startup time, and low memory footprint. Be careful that this is an experimental image. So it is not recommended to be used in production workflows, but it is ideal for local development and testing. We'll be deep diving into the details of this in further slides.
Yeah. Before we dig into the internals of the Docker image, let's have some adoption metrics. Here we have two numbers. That is the daily pulse. That is the daily pulse of the Docker image and the weekly pulse. So the Apache Kafka native Docker image was released in the end of month of July. And within a single month, you can see that the number of daily pulls have increased to more than 3,000. And similarly, the weekly pulls are touching 15,000. So this shows an exponential increase in the adoption of this Docker image and giving us the confidence that the people are liking it. Yeah, this is the official Docker Hub page of this Docker image. The name of the image is Apache/Kafka-native. Yeah, this image is under the hood of Apache. It's a sponsored OSS image, and it's for two architectures, AMD 64 and ARM 64. The tagging of this image follows the Kafka versioning. That is, if Kafka releases a version like 3.8.0, so a 3.8.0 tagged image will be packaging the same version of Kafka. And if you want to use the latest Kafka version, then just use the latest tag for the Docker image. Yeah. Now let's look at some of the comparison metrics. We have compared this Apache Kafka native Docker image with the already existing Kafka Docker images, and mainly focusing on three key metrics. That is the size of the Docker image, the startup time, and the memory footprint during the startup. So here are two of the most widely used Docker images for Apache Kafka. So CP Kafka, the size of the images in the compressed form is 457 MBs. The startup time of the container, that is from the time of creation till it is ready to serve the request, is 3.4 seconds, out of which 681 milliseconds is being used by the startup of Apache Kafka server. And the memory footprint is 420 MBs. Similarly, below are the numbers for the Bitnami Kafka. So recently, we also contributed the JVM Apache Kafka Docker image, which was also quite optimized. The image size of that image is 200 MBs. Startup time of the container is 1.63 seconds, and the memory used is 300 MB. Now let's look at the numbers of Kafka native Docker image. The size of the image is only 47 MBs. The startup time of the container is less than 300 milliseconds, and it takes only 120 milliseconds for the Kafka server to come up. And the memory used is 180 MB during the startup. So let's understand this in terms of percentages. The size of the Kafka native image is like 76% smaller as compared to Apache Kafka Docker image size, and around 90% smaller as compared to CP Kafka. The startup time, it is faster, like 81% times faster as compared to Apache Kafka, and 91% times faster as compared to CP Kafka. Similarly, it uses 40% less memory as compared to Apache Kafka, and 57% less memories as compared to CP Kafka. So this image particularly stands out with these exceptional numbers. These numbers are also proving that the image is very lean, quick, and less memory intensive. Now let's look into the performance metrics as well. So we ran a test where we brought up a container, a Kafka container, did some produce consume, and then we stopped and destroyed the container. And we ran this test 100 times. So when we ran it with CP Kafka Docker image, it took around 5 minutes to complete this test. With Apache Kafka, it took like 3 minutes and 20 seconds. But with Kafka native, it took only 1 minute and 28 seconds. It's like 50% faster than Apache Kafka and 75% faster than CP Kafka. Again, proving its efficiency and performance.
These are some amazing numbers. Let's take a look at how we were able to achieve these numbers. Before we get into that, I would like to discuss about GraalVM native image. GraalVM native image is a technology that allows us to compile Java code ahead of time and get a native executable binary. The great thing about this native executable binary is that it only contains the code that is required during the runtime, which means it's going to contain your application classes, your library classes, your language runtime, your statically linked native code from the JDK. Having this technology allows us to get some features which we took advantage of to implement and accommodate in our image. Let's go through all of them. Since we are doing ahead of time compilation, which means that we do not need to rely on just-in-time compilation for our compilation itself, this gives us a faster startup time. Secondly, since we do not require JVM to run this binary, this means that we do not need to wait for Java to boot up our application before our application starts. Moving on, given that, again, we do not require JVM for this executable, that means there is no overhead in memory footprint, which results in a lower memory footprint. Secondly, there is no need for dynamic class loading because everything is already compiled ahead of time. That means we will further reduce our memory footprint. Lastly, we were, again, since we do not require JVM, that means that any containerization of this application will not require JVM in its base image, which will result in a very lightweight base image.
So we all know that in Apache Kafka, there are many operations that happen dynamically at runtime, like including the dynamic class loading, reflection, use of JNI, or loading external resources like files or URLs. And JVM effectively handle all these things. However, as Vedarth mentioned, that the GraalVM native image tool builds the standalone native executable by performing the static analysis. So, and it all packages all the elements which are reachable from the application's entry point. But this method cannot always guarantee all the dynamic use cases are being packaged exhaustively. So, to address this, GraalVM allows configuration files during build time to specify program elements access dynamically at runtime. So these files are known as like reachability metadata or config files. And when they are being provided during the building of the standalone native executables, it tells the native image tool that, okay, you have to package these dynamic features as well into the native executable. Cool. But for large applications like Kafka, manually listing all these dynamic resources is very challenging. So to simplify this, GraalVM again offers a tool called Native Agent, which automatically generates the configurations for us. We just have to run the Kafka application with GraalVM JIT and Native Agent attached. And it will capture all the dynamic metadata while the application runs, covering all the touched code paths. But how can we ensure that we touch all the code paths? So for that, we made use of the Apache Kafka system test, which are quite extensive. So we ran all the Apache Kafka system test using GraalVM JIT and native agent attached, and it created the reachability metadata for us. And you can see we have put an example how we are bringing up the Apache Kafka using GraalVM JIT and native agent attached. And this will, once the system tests are done, it will generate a bunch of files which in the format that native agent requires. Now, once it is created, we just have to provide those configuration files during the building of the standalone native executable. You can see that here we are providing reflect config.json, jni config.json. These all files were created when the native agent was attached while running the system test. So this is how we are handling the dynamic features of Apache Kafka here.
All right, that sounds cool. Now let's look at some key details of this Docker image. First of all, let's look at some packaging considerations. We'll be only supporting craft mode. Given that Apache Kafka is transitioning away from Zookeeper, this decision aligns with that direction that we are going with Apache Kafka. Secondly, GraalVM version that we'll be using to generate our native executable binary will be the latest LTS version of GraalVM Community Edition. Currently, that is GraalVM Community Edition 21. Finally, Scala version that will be using for the Kafka binaries will be Scala 2.13. In terms of reliability, we have made some modifications to Apache Kafka system tests, which allows us to now run the system tests for native Apache Kafka image. This activity has given us confidence, as we were able to get the same results as JVM-based Apache Kafka was getting in system test result in the native Apache Kafka image as well. Secondly, we have also made some changes so that when running the system test locally using Docker, if you want to run it using native Apache Kafka image, you can do that. Also, in the release process, when a release candidate is voted on, we are also going to publish the system test report of native Apache Kafka image. This will allow us to be confident that the parity of system tests, at least from a system test point of view, will be maintained between JVM-based Apache Kafka and the native image Apache Kafka. Secondly, we have introduced Docker sanity tests. Docker sanity tests allow us to ensure that the functionality of the Docker image itself is maintained and does not differ from the previous versions. So this is a guarantee kind of thing. We have also introduced a nightly CV scanner job, which allows us to keep track of various CVs that are coming in our Docker image and allows the community to act on it if it entails, for example, a bug fix release. Moving on to the release timelines, Apache Kafka native image is going to be part of the standard Apache Kafka release. That means from every release, from 3.8.0 version onwards, Apache Kafka will contain the Apache Kafka native Docker image as one of its artifacts. This is going to ensure that this Docker image will be available in future versions. Similarly, for bug fix release versions as well, every bug fix release version beyond 3.8.0 will contain Apache Kafka native Docker image.
Yep. So we are providing a method by which we can start the container using this Docker image quite quickly. We have packaged this Docker image with some default configs, which can bring up basically minimal set of default configs, which can bring up the Kafka server up and running. So to get started, we have to simply pull the Docker image using Docker pull command. And since the image size is only 47 MBs, it will get downloaded in like few seconds only. After that, you can launch the Kafka container using the Docker run command and mapping the ports, and no other configuration is required to start up the Kafka container. So this feature is quite helpful for anyone who is new to the Kafka and wants to play around or do some experiments. Also, it is beneficial for anyone who wants to do some quick local testing, as well as it is perfect for those for use with test containers, offering a seamless experience for the integration test. Yeah, but although the quick start feature is quite good, but in many cases, we need to add some custom configurations based on the specific use cases. To address these real-world scenarios, we offer two solutions to add the custom configuration. Yeah, but before proceeding, I would like to add that configuring the Kafka native Docker image is exactly same like configuring the Apache Kafka, the JVM-based Docker image. So if you are already using that image and want to try this out, you just have to change the name, and the two solutions that we will be discussing will remain same for this image as well. So yeah, the first method is using the environment variables. We can pass the Kafka server configs using the Docker environment variables, but it needs to follow some rules. Let's look at them. So, yeah, if the Kafka server config contains a dot, we have to replace it with a single underscore. If the original config contains an underscore, you have to replace it with a double underscore. And if it contains a dash, just replace it with a triple underscore. Now prefix the result with Kafka underscore and convert everything to the uppercase. This will be the resultant environment variable corresponding to that Kafka server config. So I've added a few examples as well. So if your server config is something like abc.def, the dot is replaced by underscore, and the resultant config is on the right-hand side, Kafka underscore abc underscore def. Similarly, in the second example, underscore is replaced with a double underscore, and the third one, dash is replaced with a triple underscore. The fourth example is the real Kafka server config like node.id. So the environment variable for this will be Kafka underscore node underscore id, but all in caps. And listeners will become Kafka underscore listeners. One more thing to note, that when we bring up Kafka in the kraf mode, we need to format the log directories, for which we need to provide the cluster ID. Though this is not a Kafka server config. So, but yeah, but this is required by the Docker container. So we can provide the cluster ID as an environment variable as well, and we don't need to do any modifications to this name, and we can just pass it as is. Yeah.
All right. So let's talk about the second way to pass configs to our Docker image. File input is a relatively straightforward way of doing things, where we just need to mount the folder containing our Kafka properties on mnt shared config path of the Docker container, and it will just work. If the same Kafka property is also provided in the environment variable method, then environment variable config value or property value is going to take precedence. But in case the properties are different, then environment variable method properties and the file input method properties are going to get merged and then supplied to Kafka running inside the Docker container. There are a couple of considerations in this approach. That is, the file names that we use for mentioning the properties are need to be exact. That is server.properties for Kafka properties and log4j.properties for log4j properties. Let's take a quick look at this example. Here we can see that the file input folder has been mounted to MNT shared config. This folder contains one file, and that is server.properties. It is a standard Kafka properties file. Now let's take a look at the environment variables that we have used. There are three cases that I would like us to pay attention to. First of all, when we are just passing cluster ID or any environment variable based config input, then we'll have to use environment variables only. File input does not support that, so we have to rely on environment variables only. In this case, we have passed cluster ID, which is an environment variable that Docker container is consuming to start up our Kafka. Second case that we have showcased here is setting the properties that are not provided in the file input case, which are these three properties, that is node ID, control quorum voters, and listeners. Since these properties are only present in environment variables and not present in the file input method, that means these properties will get merged and then supplied to Apache Kafka. Third case is overriding an existing property or the conflict case. In this scenario, we are passing process roles, and if you look at the file, we have also provided process roles in server.properties file. In this case, since environment variables take precedence, we'll be running the Kafka server in combined mode, that is broker controller value will be the one that will take precedence. Right.
So this image, this Kafka native image has also been integrated with the test containers. As we all know that test containers is a widely used open source framework for provisioning throwaway on-demand containers for development and testing use cases. So recently the team at Atomic Jar worked on it and integrated it, added support of this image to the Java test containers. And this will greatly simplify the process of integrating this Docker image to our test. This feature is available from the version 1.20.1 of Java test containers. Here's a sample code how we can make use of this Docker image using test containers. Just import the package, instantiate the Kafka container using this image, and just start it. And we can write our test. So this image does have a lot of good things, but it does come with its own set of limitations. Firstly, as told in the beginning of the session, that this is not recommended for production. Why? Because the reachability metadata that we were creating using the native agent, we can never guarantee that we have the reachability metadata have the complete set of dynamic features. Since we can't guarantee that, we can't recommend it for production use case. Also, there are a few applications in Kafka where we can provide jars externally, which the Kafka will be using. So this again won't be supported because the native executable is standalone executable, and it can't interact with any jars from outside. Although if someone wants to create their own native executable, they can do it. They just need to add those jars in the class path and build the native executable. Then that particular jar will be the native executable will be able to access it because it is already present during the build time. The other con is that debugging native executable Kafka is a bit difficult. Yeah, because in Java it's quite easy to use a debugger and then we can debug it. But yeah, there are a few ways we can add debugger here. GraalVM does provide, but yeah, it's not as straightforward. Thirdly, we need to regularly update the metadata configs for the native image of Apache Kafka. So basically, if someone is contributing to Apache Kafka and they are adding some dynamic features, yeah, we'll need to update it again, the metadata configs. The GraalVM native image that we are using is community version, and it comes only with the serial GC. So yeah, that's again one of the not a drawback, but yeah, G1 GC is a better garbage collector to use. And lastly, there are multiple runtime adaptive optimizations that JVM does, which again won't be available in this native image executable.
All right, so let's talk about the Apache Kafka Docker images that are available from Apache Kafka. We just talked about native Apache Kafka, which was delivered in KIP 974. This Docker image is ideal for local development and testing use cases. It's very lightweight, it's very fast, and it takes very small memory footprint. It is not recommended for production use cases, but the good thing is that this image has exactly the same way to configure as the JVM Apache Kafka, that is KIP 75. This was delivered at the point of 3.7.0 and is of course still part of the normal Apache Kafka release process. And yeah, the good thing about this image is that it is JVM based, so it's going to do everything that you expect Apache Kafka to do, and it's going to perform just as well and can be used for production use cases. And you can have a development proper setup where you are like doing testing on the native Apache Kafka image, and you are like doing the production stuff in the JVM based Apache Kafka image, and all you need to do is just swap the name and it will just work, because again it's exactly the same way to configure these images. Finally, we also have a Docker official image for Apache Kafka, which is coming soon. It was delivered in KIP 1028, but yeah, it will have all the advantages of a Docker official image, and it will be hosted by the Docker Hub community. So yeah, that brings us to the end of this session. Please let us know if you have any questions for us. Thank you.